Hello everyone, welcome back. In today's video, I'll be talking about how to measure full width at half maximum. So this is in short called as FWHM. So this is used to calculate on XPS, XRD as well as IR and UV graphs, or you can also have any graph which has got a peak and then you can do an full width half maximum. So what is the use of this full width half maximum? It depends on the technique in which you use it or in the graph in which you perform. Generally, the full width half maximum is what is the maximum point of your curve or your peak, and then what is the half maximum of your peak, and then what is the width at the half of the maximum. So the point of which is called as full width half maximum. And why is this full width half maximum so important? So whenever we have a peak, so in probability or in dynamics, what it is called as full width half maximum. So when you look at a Gaussian distribution or a normal distribution, so Gaussian distribution is called as a normal distribution curve. So this distribution is a distribution of a data points across your curve. So what is the probability of finding the data point again in the curve when you do a second measurements is given by the graph in the given below. So you could see that when you every peak is symmetry most probably. So there are also symmetric as well as unsymmetric peaks. In most probability, the peaks are symmetry in nature. So when you have a symmetric peak and then when you have a symmetric peak, you would see that when it is divided into half, so the 50% goes here, on the right hand side, and then the 50% goes on the left hand side. So you could see that the maximum probability lies in between the above the full width half maximum. So let's say like the full width half maximum would be here around the line below I would draw a line here. So the full width half maximum could be here. So I would change the color so that it is easily visible. I'll change it to red. Yes, and then I'll increase the size to 5. Let's say the full width half maximum is here. So the probability of getting the data point again in the same line is more higher than as compared to any of the area in the point. So that is why the full width half maximum is very important. So it depends on the technique in which we use. For example, if it is in XRD, for example, in case of XRD, X-ray diffraction analysis, you would see that the full width half maximum is sensitive to various structures like the microstructure. So if the microstructure of your sample varies, then your full width half maximum would vary. Also, the stress and strain of the material could vary. So if you are a material scientist or someone who works in the material, you would see that you would get the same peak position, but your full width half maximum would keep varying over a period of time if the samples are changed. For example, the one commonly used thing is that the full width half maximum is used for calculating the grain size and the crystalline size. So the grain size of the particle and then the crystalline size of the particle. So the grain size and crystalline size are slightly different, but in technically you would say that the size of a small crystals or the microcrystals in which it has been there in the sample. So each grain size and then each crystal size are different. So for example, the XRD graph shown here is that you could see that the maximum peak here is 001 and it corresponds to a particular plane, which means that out of the crystal, out of the same sample, this crystallite phase is more predominant as compared to the other. The more narrow it gets, the more variation it has. The broader it gets, the broader the variation it is. So therefore how can you say a peak is broader, or how can you say a peak is narrower? So this is calculated by something called as full width at half maximum. So this is a standard term which is called as FWHM that is used to represent all these parameters in XRD. When it comes to XPS, so XPS is another technique which acts like a fingerprint to understand the chemical state of an atom, not a molecule. It is going to help you to understand the chemical state of an atom. So the full width half maximum analysis in XPS would tell about the surface roughness of the sample, chemical interaction. So what are the other interaction these chemical interactions can have for a particular kind of an atom, preferable crystallite size, and then the structure, and then the crystal structure of the sample. All these informations can be derived, or it can be useful to compare between one peak and then the other peak while calculating the full width at half maximum. In case of UV visible spectroscopy, people calculate full width half maximum. So FWHM, this influence the sample of analysis and then the clarity of results. For example, if we have a same concentration and then the size distribution is same, you would have always the same full width half maximum. In pharmacology or in pharmaceutical industries, this full width half maximum helps to identify the purity of a compound and then the repeatability of during the synthesis of different drugs. So in case of pharmaceutical industries, this UV visible spectroscopy and full width half maximum is a very, very important criteria to have control on the quality and then the production size. And then it can also be helps you to understand the size distribution and the concentration comparison in case of nanocolloidal solutions. In case of IR spectra, the full width half maximum gives information about the structure of the atom as well as the concentration of the particular sample, and then what is the intermolecular interaction between the sample. So you may have different interactions like OH peaks as well as CH peaks, and then there is like COOH peaks. So these peaks can be differently identified by calculating the full width half maximum, and this full width half maximum is generally used for comparison between the one data and then the other data. So now let's go and find out how to analyze the full width half maximum. So I'll go and create a new workbook. So when I create a new workbook, I would import a data. So we'll import only one single data. So I'll go to data. In the new version of Origin, the import feature is available in data. In the older version of Origin, import feature will be available in the files. So when you go to data, go to import file, go to import wizard, and then you can go to this three dots where you have a can click here and then go to the files in which you wanted to select. And for our analysis, I'll just select maybe 2 and then add file. So the selected files will be here and then click OK. So for this analysis, we are going to use only one graph, so that I will tell you how to use full width half maximum, how to calculate full width half maximum. So just give finish and then your data is imported. Yes. So this is an XRD data. So I'm going to select a X and Y and then go to come here and then plot a line graph. So when I plot a line graph, this XRD is a very good XRD. So it is quite neat. So it doesn't have any baseline correction. So if it needs a baseline correction, you could do, you can go to analysis, peaks and baseline, peak analyzer, and then open dialog box. So there is also one more video in which I have given in detail how to do a baseline correction of the XRD. Please do refer it if you have any difficulty in doing a baseline correction. And after the baseline correction, you would see a straight line here of the baseline, and then you will have peaks. So the other peaks, the smaller peaks are very small, so that, and then the higher peaks are, this peak is very high. The intensity of this peak is very high. First, we'll go and analyze the intensity of the highest peak, and then the full width half maximum of the highest peak, and then the smallest peaks. So I'll go to this option where you can say scale in and click it here, come here, and then I'm going to select the area in which I required, and then just leave it. Now go here again and then select the pointer. So now we'll come here, we have selected the pointer. So now this is the peak in which we need to do a full width half maximum analysis. So very simple. There are multiple people saying that you need to create a baseline to have an accurate one, but the baseline fitting is not required if you have already fitted the baseline for the spectra. And then come to peaks and baseline, go to multiple peak fit, open dialog box. So when you open dialog box, there is a dialog theme. So you do not have to worry about this. And then what is the import? So this is the import data in which it is going to show. So it is going to import from the graph 4. It is going to do an analysis on the graph 4. And then the range is also fixed that we selected. So x-axis is theta and y-axis is intensity. That is from the workbook in which we have created. And then the most important thing is peak functions. So there are multiple options here available. These options are the formulas in which it is used to fit the peak. And the most popular formulas are Gaussian, and then these are the two important ones. So whereas the Gauss amplitude and then the Gauss modulus are different. So everything is a different mathematical function or a probability function to make your fit the peak very good. I think the best fit you can get it is in the Gauss or in the Gaussian. If your peak is not so good, you can do it in the both the ways. So I prefer doing it in the Gauss and then going to click OK. So when you click OK, the first thing is that double click to select a peak. So you can do multiple peak fitting or even a single peak fitting. So come here, keep it and then do a double click. So when you do a double click, there is a plus sign, like a red line going downwards and then the red line going across. So this is the one saying that you have picked one peak, and then you should go to open linear fit. Do not click fit, because if you click fit, it will automatically fit the peaks, everything. Go to NL fit, which is like non-linear fit. We are going to open the function and then see what is the best fit it can have. So there is a window pops up. In the window, you could see that the recalculation mode is manual. You can either keep it manual or you can give it auto. So what is manual? We'll keep it manual, and then we'll go to the settings. When you go to the settings, again, all these options comes up. You could see that the function selection. So this is the function in which it is being used. We are going to use the Gauss function, and then iteration is logarithmic, and then this is the iteration. You can either give orthogonal or live it the same way. And then you can come to data selection. So this shows where is the data. Fitted curve, we didn't fit the curve, so it doesn't give. And then advanced. When you come to advanced, you can also vary the multiple parameters here, like the peak height percentage, and then the peak finding method. You should find it as a local maximum or window search, something. So we are going to use a local maximum. And then fit control. So these things are already controlled. So in case, so maximum iteration, this function can go with 400. If your peak is not fit above 400, still you can change the iteration and make it like more. And then the tolerance, so other parameters are here. So most probably a good peak will be fit bit below the 400, this one. And then what is the output, how should be the output requires. And then when you come to code, this will give you what is the function it is going to use it. For example, this is y equals to y0 by, and this is the function. So when you come to settings and then change the function selection, let's say I'm going to give as big Gaussian, by Gaussian. So this by Gaussian is going to give a different code. So you could see if this is there and then else do this. So this is the function it is going to use and then fit. And then that is why I said like Gauss and Gaussian functions are almost similar, which do not give the multiple variation in the spectrum. So the best function you could use as the Gauss function. And then if in case your Gauss function is not working, then you can give it as a Gaussian function. The all other functions also would help you to fit the curve, but it is used for a different purpose, not finding the full width at half maximum. So, and then I'm going to go to, instead of giving fit, I'm going to go to the column. So when I selected the Gauss fit, there is a red color line, and this is the peak fitting. So either if you give this option, fit until it converges, or you can also fit one iteration over the other. Iteration is nothing but a step. So I'm going to just forward on few iterations and then check how it is going to happen. So I'm going to give first iteration. The peak has come down. You could see that the width has come down, and then I can give second, I can give third, I can give fourth, I can give fifth. Suppose in this case, if I see that the peak has fit better, I think this is the best fit, I can click fit and just calculate the full width at half maximum. But if I wanted to do a 100% calculation or not do it manually, I'll just click this button called as fit till and until converged. I'm going to click this. So you could see that it has taken 16 steps to converge this file. Let's say like I'm going to give it in the Gaussian and see what is the difference. I'm going to give it in Gauss, different function, and I'm going to see this. So when I click on the first iteration, it has fit here until the end. So it is almost the same. In case of Gaussian function, it has taken almost 26 steps. So we'll go to Gauss function only and then click fit until it converged. I'm going to click here. It has taken multiple fit converged, and this is the best fit it can give. So this is at the full width at half maximum. So now what I'm going to give is I'm going to do an OK. So when I click OK, there is a lot of calculation goes on, and the origin does a lot of calculation, and then it gives me a value in the. So this is my workbook. There is a second sheet which is called as NL fit peak 1. So non-linear fit peak 1. If I have selected multiple peaks, then it will be like peak 1, peak 2, peak 3 and peak 4, something like that. So this is the peak curve. So what is the iteration it has taken and how much the values it has been given. So this is the one. So when you click NL fit peak 1, so you would see that the full width half maximum is here. So when you go to parameters, you can see that what is the y0, what is xc, which is the constant, w, a and sigma, and then this is the fill width at half maximum, and this is the peak height. So, and what could be the standard error in all these values are this. Suppose you should also consider it this value error. If the value error is like close to, it should be close to zero as possible. If it is close to 1, then your peak is not fit perfect. So then you have to do a different calculation with using a different parameter. So this is the full width half maximum, and then always keep in mind the error. So error should be as low as possible. And then it will also give you the function, and it is there. It is the input data. So this is the input data. And if you go to node, and then you would see this is the equation that is used for this calculation. Suppose if you are using different version of an origin, and then, or if you are using a different software to perform a different peak fitting, I think you should have a note of this equation where it could see that what is the Gaussian function or what is the function it is using to fit the peak. Suppose if you are going to use the same function for any graph, it should give similar full width at half maximum value, and then your two full width half maximum values are comparable only when their functions are same. Suppose if one has calculated using Gauss function, the other has calculated using Gaussian function, then the formulas are completely different, and then their full width half maximum can also be different. So remember that when you're going to compare the two full width half maximum, you should consider the equation also. So whenever you publish or whenever you write a thesis or a paper, you should also give what is the equation that is used to calculate the full width half maximum, so that it has been a proper reference so that somebody can compare it. So these are the datas, and here we have the full width half maximum. So now we'll go back and see, try to fit the smaller peak. So there are also multiple peaks in the XRD graph. So I will go and fit the other peaks. So let me plot again, and then I'll select the smaller peak, which is around 55, going to scale in option, and then scale in the required peak, and this is the required peak. Since the intensity of the peak is very small, I doubt it would converge it very well, but still we'll go and see. Go to analysis, peaks and baseline, multiple peak fit, open dialog box, and then Gauss function, click OK, select the peak. I think this is only one peak, and then open lawn. Okay, it has not come. You have picked 0 peaks. I have to pick the peak again. Cancel. Analysis, multiple peak fit. Okay. So whenever the peak is selected, you have picked one peak, and then you should have such the extending red lines, open non-linear fit, and then I'm going to have a note of these Gaussian again, and then this is the function. So it is the same function as before, and I'm going to give fit. So when I'm fitting, it would fit me the data, and then it should give me the full width half maximum. So when you see here, there is a full width half maximum given here, which is 40, and you see the standard error. So this is a very, very high error for a peak. So this is arising because the peak is not fit properly. Second, the peak cannot be fit properly using the Gauss function. So that is why you are not able to. Let's go to the graph and find out. You could see that this is the graph. You could see that the peak is not at all fit. It has just been the linear line. So this is because the point of which this and then the intensity of this is comparatively lower. So there is a very small difference between the baseline, and then there is a small difference between the top of the peak. So that is the reason why the peak is not able to fit. So that is why it is not fitting. So this peak cannot be fitted So you cannot use Gauss function or any other function to fit the peak, since the intensity of the highest point, or the highest point, which is the peak of the highest intensity point, and then the baseline is very less as compared to the whole graph. So that is the reason you are not able to fit it. Now we'll go and see what is the difference in the intensities. You could see here the small peak is here, whereas the large peak is here. So this is a very high. So for a peak to have a good fitting, you should have a good intensity from the baseline. You should have a good difference from the baseline. If not, the Gaussian functions cannot fit. Then you will have to try a different functions and then try to fit the values. So I think that's all. For a large peaks, you can do it when the intensity is high. When small peaks, you cannot do it. And then the full width half maximum data can be found out here. For example, here, this is our workbook and this is the first sheet. First sheet gives you the data and second sheet is the nonlinear fit of peak 1, and the equations can be found in the notes, and then the full width half maximum value can be found in the parameters, and then this is the value and this is the standard error. The error should be lowest possible, close to 0. And this is the second one, and you could see that it has used the same formula, and then it has used the same input data but in a different range, and then the full width half maximum value and the standard errors are very different. So it is almost 50% value can change. So it is like 25% to 30% value can change. So because the whole value is 40 and then the error value is 13.3, so which is almost like so much of variation in the full width half maximum. So you cannot depend on this value. So the peak fitting is not proper, or the peak cannot be fitted. So these are the two informations that we can do it, and these are the informations of the curve. So I think these can be extended to anything like XPS, XRD, UV visible, and IR spectra. So the concept is same. So whenever you go to analysis, whenever you have a peak, you select a peak, zoom it as that only one peak is selected, go to baseline and then do a multiple peak fitting. Select only one peak at a time, or you can do also multiple peaks if they are actually separate, and then you can find the full width half maximum. And please note down the error value. So the error should be as low as possible, like close to 0. And then I think that's all. Thank you for listening. Have a good day.